to come on the dais, please. And I request Professor Dhar sir to welcome Dr. Bacha Babu sir, who is Head Department of Mass Communication and New Media. Thank you so much, sir. So, sir, I want to summarize that today we are focusing on satellite and meteorological data analysis. We are having with us Professor Sadhnik Dey, Institute Chair Professor from IIT Delhi. So, in this session, we are going to discuss more on hands-on training for using this data, and we'll be continuing with this presentation. But before that, I would like to invite you to share your views on C4SD, Way Towards Atmanirbhar Bharat. Sir's abstract is available at page number 54. Sir, please.
बहुत बहुत शुक्रिया श्वेता मुझे बुलाने के लिए। मुझे लग रहा है ये 20 तारीख से आज हमारा तीसरा दिन है ना, चौथा हो गया। ये विंटर स्कूल का जो इवेंट है आज अब लगभग अपने अंतिम पड़ाव पे है। कल खत्म होगी, परसों। तो हम मतलब मध्य में हैं। इससे पहले कि मैं अपने बात रखूं, सबसे पहले तो इस पूरे आयोजन की, जिसको मैं कह सकता हूं कि एक कड़ी, जहां से विश्वविद्यालय में उस दिन मैं सुन रहा था कि जी साहब जब आए और इस बात की तारीफ हुई कि भाई 19 से जो एक पूरी परियोजना चली थी पर्यावरण को लेके जम्मू कश्मीर में, तो मैडम श्वेता को इसके लिए बहुत बहुत बधाई, क्योंकि बहुत कम संसाधनों में ये प्रोजेक्ट शुरू किया गया था। हम सब उसके गवाह थे और मैडम ने बहुत सारे इक्विपमेंट खरीद लिए थे, जगह नहीं था हमारे पास और हम सब मिलके ढूंढ रहे थे कि प्रोजेक्ट को फंक्शनल करने के लिए विश्वविद्यालय में हम कहाँ लगाएं। तो कभी किसी लिफ्ट के बगल में, तो कभी किसी बाथरूम के बगल में। तो कहने का मतलब ये है कि कितनी मुश्किलों से इस तरह की जो महत्वाकांक्षी परियोजनाएं हैं उसको लेके विश्वविद्यालय में और एक फैकल्टी का कमिटमेंट है। तो मैं इसके लिए इनको बहुत बहुत धन्यवाद दूंगा कि आज के हम बहुत कुछ जो है कर पा रहे हैं, लेकिन शुरुआत में बहुत मुश्किलें हुई थी। क्योंकि मैं मीडिया से बिलोंग करता हूँ और मीडिया का शिक्षक भी हूँ, समाज में घटने वाली जो तमाम घटनाएं हैं उस पे हर रोज थोड़ी बहुत मेरी नजर रहती है। आज सुबह सुबह मैं अपने विद्यार्थियों से इस बात का जिक्र कर रहा था कि आज एक खबर के फ्रंट पेज पे, एक अखबार के फ्रंट पेज पे एक खबर आई और खबर ये थी कि हैदराबाद की एक बहुत बड़ी संस्था है जो प्लेट टेक्टोनिक पे काम करती है। तो उनका ये खबर था कि हर साल जो है, जो भारतीय प्लेट है, इंडियन प्लेट जो है, वो 5 सेंटीमीटर की रफ्तार से खिसक रही है। और ये चर्चा इसलिए भी है क्योंकि विश्व में एक बहुत बड़े भूकंप हमने अभी सीरिया में देखा। बहुत सारे लोग उसमें जो है, अभी तक वो हम लोग सही डाटा नहीं इकट्ठा कर पाए कि कितने लोग उसमें जान गंवा चुके हैं। तो कहे कि भारत में किसी भी वक्त इस तरह की भूकंप आ सकती है और उसका जो एपिसेंटर होगा वो एपिसेंटर हिमालयन बेल्ट होगा। उसमें उत्तराखंड, हिमाचल, जम्मू कश्मीर, पूर्वी नेपाल, इस तरह के हिस्से जहां नए जो है जो संरचनाएं हो रही हैं उस पे मेरे जहन में ये खबर बहुत दूर तक असर की। और मैं आज अपने सुबह की क्लास में मैंने इसी विषय पे लिया कि हम किस वाक़ों की जिंदगी में जी रहे हैं जबकि हमारे पैर के नीचे से जमीन खिसक रही है और हम एक नई दुनिया बसाने की बात कर रहे हैं, चांद में जाने की बात कर रहे हैं, आप चैट जीपीटी की बात कर रहे हैं। और इसी विषय पे कहीं ना कहीं मेरा ये पेपर भी था कि अब तक जो कम्युनिकेशन का जो पूरा मॉडल था उसको हम CCC में डिवाइड करते थे कि कम्युनिकेशन में जो बाजार में बिक रहा है मीडिया को उसको दिखाना चाहिए, लाइक सेलिब्रिटी, लाइक क्रिकेट, लाइक क्राइम बहुत बिकता है मीडिया में। हमने कहा लगता है अब सी से जो है थोड़ा शिफ्ट होने की जरूरत है, और इसी वजह से हमने इस विषय का रखा कि सी फॉर सस्टेनेबल डेवलपमेंट। इससे पहले मैं अपनी बात रखूं, एक मुझे बहुत मशहूर इन्वायरमेंटलिस्ट है ग्रिफिथ टेलर, जो पर्यावरण से जुड़े लोग होंगे वो जानते होंगे, ब्रिटिश मूल की वो ग्रिफिथ टेलर है। उनका एक बहुत अच्छा एक उद्धरण है, स्टॉप एंड गो डिटर्मिनिज्म, यानी रुको और चलो नियतिवाद। इस पे ग्रिफिथ बहुत पहले कितनी दूरदर्शी थे, वो बार बार मनुष्य और पर्यावरण या मनुष्य या प्रकृति के बीच के संबंधों को लेके ग्रिफिथ टेलर अपने स्टॉप एंड गो डिटर्मिनिज्म में अपनी बात कहते हैं। और वो ये कहते हैं कि प्रकृति जो है एक ट्रैफिक कंट्रोलर की तरह है, एक ट्रैफिक कंट्रोलर की तरह है, जो ट्रैफिक कंट्रोलर जो भूमिका अदा करता है कि आपको कब चलना है और कब रुकना है। रेड लाइट पे हम रुकते हैं, ग्रीन लाइट पे चलते हैं। तो प्रकृति भी आपको बार बार जो है इस तरीके से इंडिकेशन देता है। और शायद वो इंडिकेशन जो है हमने देखा कि पिछले कुछ सालों में हमारे सामने वो बिल्कुल जिसको कहते हैं प्रत्यक्ष रूप में ग्रिफिथ टेलर की बात बिल्कुल सत्य हो रही है कि प्रकृति बार बार जो है ये अपना इशारा कर रहा है। हमने देखा अभी उत्तराखंड में क्या हुआ, इतना बड़ा जोशी मठ की हालत जो है हम सबने देखा। देश में जो है हम जिस अभी जगह पे बैठे हैं, हम यकीन नहीं कर सकते थे 2-3 साल पहले की बात बता रहा हूँ कि हम 2013-14 में यहाँ आए हैं और पहली बार ऐसा है कि फरवरी में हम एक शर्ट में बैठे हैं। मुझे याद है 5 मार्च 2014 को मैंने ज्वाइन किया था और पूरी तरह से कोट शोट लगा के, हाई नेक लगा के, तो मुझे लग रहा है कि अचानक से ये पिछले 3-4 सालों में क्या हो गया। फरवरी में इतनी गर्मी जम्मू कश्मीर में हमने नहीं देखी थी। और ये सिर्फ जम्मू कश्मीर की बात नहीं है, तमाम उस तरह के प्रदेशों की बात है जहां वो प्रदेश प्रकृति के सबसे करीब रहा है। और जम्मू कश्मीर भी उसमें है कि हम प्रकृति के सबसे करीब रहने वाले लोग हैं। और इस तरह की जो चीजें जो है, इस तरह की जो बदलाव है, ये कहीं ना कहीं जो है एक सोचने की बात है। और ग्रिफिथ टेलर की जो स्टॉप एंड गो डिटर्मिनिज्म की जो थ्योरी है, आज वो प्रकृति का जो ट्रैफिक कंट्रोलर है बार बार हमको इशारा कर रहा है कि अब रुक जाओ, अब रुक जाओ, अब रुक जाओ। लेकिन लगता है कि शायद हमने ठान रखा है कि जमीन हमारे पैर के नीचे से हम गुजर के ही मानेंगे। बार बार यूनेस्को ने इस बात पे, मैंने जिस पेपर को कोट किया था वो यूनेस्को की एक रिपोर्ट पे बेस्ड था। यूनेस्को ने 2007 में एक रिपोर्ट प्रेजेंट की जिसमें कम्युनिकेशन की स्ट्रेटजी पे बेस्ड था वो, कि कम्युनिकेशन का आने वाला जो स्ट्रेटजी होगा वो क्या होगा, किस तरह के मुद्दों को, क्योंकि खासकर इंडियन मीडिया बहुत सारे क्रिटिसिज्म होते हैं कि हम बहुत हार्ड स्टोरी को नहीं लेते हैं। हार्ड स्टोरी मीन्स कि अनएम्प्लॉयमेंट लोगों की बात, पॉवर्टी की बात, इन्वायरमेंट की बात, हम इसको ज्यादातर नहीं उठाते हैं। बहुत कम ऐसे न्यूज़पेपर या आपको न्यूज चैनल मिलेंगे जहां दिन भर में कभी आपको किसी इन्वायरमेंट के इशू पे आपको डिबेट करने को देखने को मिलेगा। तो वो स्ट्रेटजी क्या होगी और सस्टेनेबल डेवलपमेंट का पैरामीटर क्या होगा। जैसे हमने देखा कि अभी G20 में जो 17 पैरामीटर है, 17 पैरामीटर में 3 पैरामीटर्स डायरेक्ट इन्वायरमेंट, जिसको आप ग्रीन एनर्जी की बात करें या सस्टेनेबल गोल की बात करें, तो उसमें 17 में से 3 जो है वो आप कैसे उसको पूरा करेंगे, उसके लिए कम्युनिकेशन की एक बहुत जिसको कहते हैं कि एक मुकम्मल स्ट्रेटजी बनाने की जरूरत है। और जो इंडियन मीडिया इंडस्ट्री है, इंडियन मीडिया इंडस्ट्री को भी जो है इस पर सोचने की जरूरत है। और 2007 की इस रिपोर्ट जो कम्युनिकेशन फॉर सस्टेनेबल डेवलपमेंट की यूनेस्को की रिपोर्ट है, इसके रिपोर्ट में एक चीज जो बहुत जरूरी से कही गई कि इसमें अवेयरनेस कैंपेन आपको चलाना पड़ेगा। और अवेयरनेस कैंपेन की जो जिम्मेदारी है, यानी इंफॉर्मेटिव सोसाइटी की जो बनाने की जिम्मेदारी है, वो कहीं ना कहीं जो है इस जो अभी बडिंग कम्युनिकेटर है या जो अभी इंडस्ट्री से बिलोंग करते हैं, उन पर एक बहुत बड़ी जिम्मेदारी है। और इसी को लेके सेंट्रल यूनिवर्सिटी ऑफ जम्मू हमने डिपार्टमेंट में एक कोर्स नया स्टार्ट किया जिसपे हमने सस्टेनेबल डेवलपमेंट को एक पूरा पेपर में रखा कि सस्टेनेबल डेवलपमेंट को अचीव करने के लिए कम्युनिकेशन की स्ट्रैटेजी क्या होगी, इस पर एडवर्टीजमेंट को लेके, पीआर को लेके, या फिर उसके जो डेवलपमेंट मॉडल्स है, उस डेवलपमेंट मॉडल्स को ज्यादा से ज्यादा कैसे आप लोगों तक पहुंचाएंगे, ज्यादा से ज्यादा इफेक्टिव कैसे बनाएंगे, इसकी स्ट्रैटेजी पे जो है आज के इंडियन जो कम्युनिकेटर है, जो मीडिया इंडस्ट्री है, उसको सोचने समझने की जरूरत है। और मुझे लगता है कि जिसकी बात अभी पहले दिन भी हो रही थी, शायद किसी वक्ता ने कहा कि अभी आपके बगल में रियासी में बहुत बड़ा लिथियम का भंडार मिला है 5.9, और इसको लेके पूरे विश्व में जिस दिन ये खबर आई उसके दूसरे दिन यूएस गवर्नमेंट की ऑफिशियल ट्विटर हैंडल पे मैंने उस ट्वीट को देखा और बड़ा गर्वान्वित फील हुआ। उस ट्वीट में था कि गुड मॉर्निंग, आई एम लिथियम और आई एम फ्रॉम इंडिया। ये ट्विटर जो है यूएस गवर्नमेंट ने अपनी ऑफिशियल ट्वीट किया इसको। तो एक जिसको कहते हैं कि एक जो ग्रीन एनर्जी की तरफ जाने का जो एक माध्यम है, उसका एक बहुत बड़ा जरिया आपके पास है। तो मुझे लगता है कि सिर्फ और सिर्फ जो है हमारी कम्युनिकेशन स्ट्रैटेजी और इच्छा शक्ति जो है वही एक ऐसा ये है कि उसे माहौल बनाने की जरूरत है, जिसको सही मायने में हम कहते हैं कि जब हम उसको पूरा करेंगे तभी जाके जो है हम आत्मनिर्भर भारत के जो कंसेप्ट है, जो पूरी की पूरी जो उसकी एक संभावना है, उसको पूरा कर सकते हैं। मैं बहुत ज्यादा वक्त ना लेते हुए आगे के वक्ता को देता हूँ। ठीक है, बहुत बहुत शुक्रिया।
बहुत धन्यवाद सर आपके एक्सेलेंट लेक्चर के लिए और काइंड वर्ड्स के लिए। आई थिंक बाय नाउ ऑल द पार्टिसिपेंट्स मस्ट हैव रियलाइज्ड दिस थिंग that Central University of Jammu, whatever is doing, the strength is the team which is existing in faculty, in staff. Pranav is there to do this live streaming, and different departments are there, different people are involved in this winter school. So whatever we are doing, it is not only the Department of Environmental Sciences, it is the complete fraternity of Central University of Jammu, because of which we are able to do it. And for that, I am very thankful to the entire Central University of Jammu fraternity under the Honorable Vice Chancellor Sir's leadership. We all are working as team and we are taking small steps. And as Sir was saying that we struggled a lot initially, but now I think the time has come that we can proudly say that we can do many more such activities. And with the interdisciplinary research approach also, I would like to invite ideas so that tomorrow we are ready for doing the interdisciplinary research also. With this, I once again thank Dr. Bacha Babu sir for his excellent lecture. And now I will request Dr. Dinesh to please thank sir for this lecture. Thank you. Now we'll continue with Professor Sagnik Dey because we interrupted him in between, and now the house is open for interaction also because it is more going to be an interactive lecture.
Okay, I will just first finish my presentation. Okay, so I give you some examples of how existing data can be improved. I also talked about some process understanding and all. What I will do now is that very quickly show new data products can also be developed using whatever we have from the remote sensing traditional data sets. And one classic example is the data that we put together for the Central Pollution Control Board, because you know that in India, the ground monitoring for PM 2.5 and PM 10, it's not very adequate. We have around 800 manual sites, but they mostly measure twice a week. So it's not continuous information. If you rely on continuous information, then you have to look for continuous air quality monitoring sites, AQMS, which is today, I think, crossed 400. But if you look into time, This particular figure shows where are the continuous sites located, and the color of the each dot shows the year from when they started operating. And you see that most of the sites were operational after 2018 or so. In fact, if you go back to 2018 or 2017, there are hardly, around 80 to 100 sites in the whole country. Now, even today, with 400 plus continuous sites, none of the sites are in rural area. So we really do not know. There is no way actually to know, what is the air quality and all. So all this gave the motivation, not to us as researchers. Obviously, we look for such opportunity, try to develop new products, but it is really welcoming to see that CPCB has understood the paucity of the data, and they also resorted to use satellite data as a complementary tool. So they asked us to standardize the algorithm for India, and that's where actually I'm focusing on, that you cannot just use some existing data product without really tuning it to the region. So how we did it? You all know that satellite gives routine product of aerosol optical depth. However, aerosol optical depth product that you get from any satellite has large spatial gap because of the cloud cover. For example, if you see the image from MODIS Mayak AOD, which is retrieved at 1 kilometer by 1 kilometer, you see that all these white areas, this is 1st January 2021. Large part of the country has data gap because of the clouds and other issues. 1st January fog could be another reason. So first what we did is that we filled this data gap using a machine learning approach. And again, you have to read the papers and on. And then essentially then what we did is that once we have this data gap filled, our algorithm is also standardized to predict or retrieve PM 2.5 at the surface level. Now AOD, you all know, is a columnar quantity. How we are converting that columnar quantity to surface PM 2.5 level using a scaling factor approach. Now, this is just to show that there are large data gaps, particularly during monsoon season, and which is obvious because that's when you have always cloud cover. And obviously, if you propose the methodology, you have to evaluate it. So first, what we have evaluated is that our gap filled AOD versus measurement. Now, when satellites cannot retrieve, the ground-based radiometers like Aeronet and any other network, they also cannot retrieve AOD, because if cloud is present, no matter whether you are measuring from satellite or from ground, you cannot retrieve AOD. So what we did is that we used a different approach. We simply considered, randomly we chose around 5 lakh data points where satellite retrieved. There was no issue, but we actually predicted using our algorithm for those pixels that if satellite could not retrieve those pixels those days, randomly 5 lakh data points are chosen, and you can see that our predicted algorithm is showing quite good comparison. So this is the first check. Second check is that when you actually calculate the PM 2.5, how it compares with the reference grid monitoring from the surface. So 24-hour level, you can see that we are able to bring down the error to around 11 microgram. And at annual scale, the error is very low, around 4 microgram. If you calculate in terms of percentage, the error is less than 7 to 8%. We have put already in the data. You go to this website called sans.co.in. As of now, you will not be able to download the data. You will see some maps, but we are working with CPCB to get the digital security clearance. And once that is obtained, then the data also will be posted there. And then this website will be hosted in the CPCB website. If anyone needs, I can share the data. So using this data, then you can sort of look into this kind of pollution cycle. Many of you perhaps seen this video, but I don't know how to run this video. Can you click on this?
Shivali, can you please help?
Can you just click on this? There is a video. You just click on that. So each day you will see this. Yeah.
Animation.
Yeah. Yes. So now you see basically as the time moves, how the pollution level changes. So there are spatial patterns, there are temporal patterns. Oh, you have to click again then. Yeah, you just keep it like that. Yeah, it's fine. So yeah, obviously in the winter time, the entire Indo-Gangetic plain having very, very high pollution level, the color scale is there. I will see that as the summer is progressing, facilitating dispersion. So many places you will see green or blue, and you still have this dust emitted from the desert region. You will see that in May now most of the central India is much cleaner. You have very high dust coming from the deserts and occasionally transported across the IGP. Now in monsoon, you can see most of the country is quite clean, except that region where still, hardly there is any rainfall. And as soon as the monsoon ends, you will again see that the pollution is building up. So this kind of data actually provides you the perspective of how weather, yeah, now you see in October onwards, again, the pollution is picking up, particularly in that Delhi, Punjab, Haryana corridor, and the pollution is kind of pushed from west to east, and then the cycle continues. Now, each day here is average of 22 years. So when I say 1st January, it is average of all the last 22 1st January. So it's not 1 year, 2 year. It's a natural pollution cycle. There are also trends in between. But it shows you that how topography, weather, and local or regional sources combine to influence the variations in the pollution level in the country. Now, if you are not measuring everywhere, obviously you will not get that perspective. Okay, can you go to next slide and then make it full screen? Okay, it's fine. So if you look into the trend over the last 22 years, obviously you will see that in winter and post-monsoon is when the pollution level is rising. Interestingly, in pre-monsoon, most of the IGP, which is pollution hotspot, there is no trend. In fact, there is a negative trend over the Rajasthan and other areas. And this is mainly because of the reduced dust activity in the recent years. In this season, you will see that peninsular India is where you actually see the rising trend. Now, if you look into the trend for the last 22 years, it is not the whole story. Why? Because if you see the last few years, which is shown in the bottom, annual PM level from 2015 to 2022, I moved 2020 above because that was anomalous year because of the lockdown and all. So, but I kept it there. You see that the pollution level typically kept on increasing till 2016 and 17 when actually it reached kind of a peak, and after that you see that there is an apparent stabilization. You see 2019 is somewhere missing, but yeah, 2019 and then 21, 22, we have not gone back to 2017 level. Ground data in the last 2-3 years, when you have decent ground data, is also indicating the same thing. Now, if you ask me why this rising trend is kind of stabilizing, obviously you need update of the emissions, but there are certain reasons which I believe one definitely is the regional scale. First of all, also keep in mind that this improvement is at the regional scale. And what we have noticed is that obviously weather plays an important role, but at the same time, the regional sources, particularly the solid fuel usage at a regional scale, has come down because of the government policies, which I personally believe playing a very important role in improving the regional level. And there are also feedback processes. If your air is already polluted, then if you add a small amount from any emission, that will increase the local concentration much more compared to a condition where your background is relatively clean. And this is because of the feedback processes. Why? Because if it is already polluted, the background, it cuts down the solar radiation, it makes the lower part of the atmosphere much stable. So you emit something, it will not really disperse easily. So the same amount of extra emission will lead to different levels of concentration depending on how polluted or how clean is your background. So these are very important again point to keep in mind. That is not always emission, it's a combination of emission and meteorology. Then with this data, actually you can think of many applications. One big application is we have identified the major air shades in the country. 4 panel shows the 4 seasons. Top left is winter, then B is summer, C is monsoon, and D is post-monsoon. You can see that mostly India is divided regionally, and this right panel shows how the air shades are identified based on the wind trajectories, topography, and then we looked into the spatial heterogeneity of the pollution levels. You see that more or less 9 to 11 major air shades. The background color in each map is the percentage of primary PM2.5 to total PM2.5. And if you see again in most of the cities, most of the places, it is the secondary PM2.5. Now this information obviously is not coming from the satellite, but this is coming from the modeling results. But what it tells us is that, and this is the case when you look into the source apportionment studies, you will always see, believe me, that the secondary aerosols play a major role. And in most of our clean air action plan, we do not talk about the secondary aerosols. We are all going after reducing dust. We are not talking about reducing SO2, NO2 or ammonia, which is actually contributing to secondary PM2.5. And then for each air shades, we have these pie charts, which are the sectoral contribution to primary and secondary PM2.5 in each of the air shade. Anyway, I mean, but the point here is actually that, again, some of the sectors are popping out, and these are the results for the NCAP baseline year, which is 2017. Now, if you do a study, for example, if I look into this map, Jammu belongs to the air shade number 1, or for example, the top left, or perhaps air shade number 2 actually, yes. And then, if you now do a source apportionment studies, you can compare how things have changed between 2017 and 2022. It would be interesting really to keep track how things are changing in each of these regions. The other example of satellite data is that because satellites is giving you a regional perspective, you can identify in future where you want to deploy a ground monitor. If you have large vacant space, and if you have limited resource, obviously you need a scientific methodology to identify where I will put my next monitor. And again, in this paper, we provided that methodology where we said that we need to prioritize looking at the spatial heterogeneity. Then where you have high levels, high trend, lot of people are living, and within each air shade, then you see that in the vicinity there should not be any immediate ground monitor. So we propose this methodology to CPCB, and they are considering this for deciding that how the network can be expanded. Now, from satellite perspective, because this type of satellite data are heavily now used in the health impact assessment. Now, I'm not discussing today health, but what I'm trying to say is that when we have been doing health studies for the last 5-6 years, we looked for multiple child and adult health outcomes. And we have started moving beyond PM2.5 mass. I'm sure you all know that all the regulations today are based on PM mass. What we are noticing is that depending on, no matter what type of study design you adopt, what type of health outcome you choose, there are differential impacts. Not all species are equally toxic. For example, this particular study, this is an acute exposure study in Delhi. You can see different species on the y-axis have different impacts. Health outcome here is the all-cause mortality. So clearly you can see, for example, ammonium nitrate or ammonium nitrate, sulfate, black carbon has much larger impact than organic carbon, dust, and some other things. Obviously, there are also differences between male and female. That's another discussion point. But essentially what we're trying to say is that now it has been established that all particles cannot be equally toxic, so more research is required before they can be incorporated into the policy. And this is where again satellite data can prove a very important. For example, you can look into this type of individual species distribution. Like this is the figures, you can see how the black carbon is distributed, how organic carbon, sulfate, dust, and all. Not only species, we all know that species is linked to the sectors, right? So you can look into the sectors now. Each sector contributing to PM 2.5, for example, domestic, road dust, industry, power. So all this you can do if you combine information you are getting from the satellite and then do some modeling. So again, recall that I started saying that one particular, if you're only using satellite, only measurement, only model, it will never give you the complete picture. So you have to start mixing them. Now, once you have this type of data, then you can do, wonder things. Actually, you can see which sector has more impact and all. For example, these studies, we've shown that for anemia, industrial sector has the largest impact. Now a mission is coming up where the user, like you, will get directly the PM composition, and you need to go all these things. All this will be embedded in the algorithm itself, and you will get PM composition at very high spatial and temporal scale for this particular region. So obviously, in India, the main region that has been chosen is Delhi NCR. But we are also coming up with algorithms to actually do this at pan-India scale. Beyond PM 2.5, we all understand that it's a multi-pollutant environment, clearly. We cannot say only PM 2.5 or PM 10. Even so, we are going to multi-pollutant, but before going to multi-pollutant, here is an example that from our current 1 kilometer data set, we have come down at city level to 100 meters. So this is example of Delhi, where we are measuring pollution level at municipal ward level. So you can see Delhi with the municipal ward boundaries, the black dots are current CAQMS. Now this type of analysis helps you to understand the representativeness of the existing monitoring site. And if you look at Delhi, what immediately pops out is that currently in Delhi, most of the monitoring sites are where actually the pollution level is quite high. We are not really monitoring in Delhi where the pollution level is slightly lower. And in a sense, in a way it makes sense, because typically you start measuring where you think it is a hotspot. So the question is that if you are using this data from the hotspot, is it really representative of Delhi or not? Now forget about Delhi, where we have so many monitoring sites. Most of the cities today have only one monitor. And if that monitor is not located at a representative site, either it will bias high or bias low. Again, you can assess actually for your city using our data set, the representativeness. As I said that beyond PM 2.5, we have a PM 10 product. We also have an NO2 product. And NO2 is always so fascinating after PM, always to me, because it's a classic indicator of transport sector as well as coal burning, typically in industrial power plant. And you can see that actually wherever you have these big cities, high traffic density along the highways, power plants and all, NO2 exposure is there. And very soon we'll come up with ozone and other data set. Last point before I end and then show some tools, that when you talk about air pollution or anything else, any clean air activity has a climate consequence. For example, if you have scattering aerosols, sulfate, nitrate kind of particles present in the atmosphere, which you are measuring, and let's say for cleaning air, you remove them. Whatever you do, you stop emitting them. So obviously there will be less scattering aerosol in the atmosphere. What will be the consequence? The consequence, because they are scattering in nature, they reflect sunlight. They cool the climate. So if you move them out of the climate system, there will be an additional or accelerated warming. So what I'm trying to say is that not all clean air pathways will lead you to positive climate impact. you need to assess different pathways and see where you are expecting climate co-benefit and prioritize them. Now, this is one example. You can see that, with respect to baseline 2010, 2 emission scenarios in 2030 under RCP 8.5, under RCP 4.5. Obviously, mitigation is scenario where you are reducing aerosol load. So, as a result, what is happening is that compared to baseline, in mitigation map, you see a lot of negative. That means there is an improvement. However, if you see, the trade-off is that in this particular case, there will be additional 0.3 to 0.5 degree warming, because in this case, mostly it is the scattering aerosols which are targeted. But because you are cleaning the air, there is a positive impact on health. So what we argued in this particular paper is that the trade-off is reasonable. There will be some warming, but you are able to save so many lives. So what I'm trying to say is that many more such scenario analysis is required before you actually say what is the sustainable pathway. And in my opinion, the sectors that co-emit greenhouse gases and short-lived climate pollutants like black carbon, for example, those are the sectors that must be prioritized. Because if you remove black carbon from the air, not only it will clean air, but black carbon being an absorbing agent, it will not lead to accelerated warming. Yes.
What is RCP 8.5 and RCP?
Oh, sorry. Oh, okay. So these are the scenarios to define the climate change. RCP is abbreviation of representative concentration pathways. So when you talk about climate change for the future, the scenarios are defined based on what will be the radiative forcing by end of the centuries. So RCP 8.5 means if you follow this pathway, end of the century, there will be 8.5 watt per meter square net positive forcing. And this is the worst case scenario. And more or less, moderate case scenario is RCP 4.5. There is another scenario, RCP 6, which is in between these two. Best case scenario is RCP 2.6, which is most likely will never attain. So I just end today with this key takeaway message that, satellite remote sensing today has great potential to provide valuable information for climate and air quality studies. I've shown some examples. Obviously, I can go on and on, but the point here is that you have to evaluate your satellite data before you do any application. You cannot just consider them as truth and start using them. Very, very important message. I've seen people, randomly left and right are using satellite data. And you have to interpret them as per their strengths and weaknesses. So this is where the understanding is required. You cannot overinterpret unless you really know what they can do. In India, we are not really doing much research in improving the existing products and derive new products. More training is required, perhaps, extensive hands-on training before you actually start doing that. But I think, there are opportunities to do that. And I've shown some example. And as I said, the best way forward is combining all the three. But obviously, as I said, that you need certain skills to really do all these things. I don't know how much time I have in this session, but what I now decided is that I will show you some websites and all where you can get some informations. How do I do that? It's there in this particular laptop. Yes. Yeah,
Sir, what type of techniques we can use for the gap filling?
Gap filling, there is no, again, uniform technique, but I think, what we have used is a machine learning model. Again, there could be multiple machine learning techniques that could be used. We used XGBoost. We did some comparative assessment also between XGBoost, random forest, and support vector machine and all. And particularly this application, we found XGBoost is giving the best performance.
Sir,
And how we did it also, since you asked the question, so there are data set. So basically, we train our model for the grids where there is data with other predictor variables. And then basically using those predictor variables with the meteorological conditions, emissions, and other things, we predicted where you are not able to retrieve AOD.
Can we use the interpolation techniques as well?
Interpolation you can use, but we have seen very spurious kind of patterns are emerging when you try to interpolate, because there is no I should say uniform pattern in the distribution of aerosols. So that's the problem when you try to interpolate.
Sir, because I was interested in this, we don't have that much of ground stations in J&K. In Srinagar, we just have one station available and data is not. So that's why I was interested to know what we can do in such kind of cases, because while talking about the data sets, whether MODIS or OMI, so data gaps are there. So how we can
for PM, I can send you the data that we have put together. If you need only over J&K, I can extract, or otherwise I can just share the entire data set. You just extract for J&K. We have the data for the last 22 years, daily basis. But if you are interested mostly in the NCAP period, also I can do that. In terms of NO2 and all, also we have the annual scale data. I don't have daily data yet. We are processing. It will take some time. But I would be happy, to discuss offline, how to actually help you in doing the gap analysis. But take me that interpolation will not work, simply because when there is gap, actually, if there are 2-3 pixels gap, you can interpolate easily. But if the gap is too large, especially, then it is almost impossible to really interpolate in a meaningful way.
Yes, sir, because we are having the gaps very spatial distribution of
Yes.
gaps. So I believe, yes, interpolation will not help.
So in that case, this type of methodology will certainly work.
So definitely, I want to
Sure.
share with you.
Absolutely.
So one more thing is, you are using only the ML techniques for the modeling.
No, only for the gap filling.
Only for the gap filling. And what about, you mentioned about the algorithms you have used?
Standardized algorithm has a bit of scaling factor approach where you are using also some chemical transport model outputs, which is combined also with some ML techniques.
Okay, thank you, sir. Thank you.
I would rather suggest that you can, and now actually we are moving to hourly data, so we can do specific data for J&K if there is an interest. But we already have the data for daily scale at 1 kilometer by 1 kilometer. But let's say for Jammu or Srinagar, you want ward level information. Then what you have to do is that, again, if you interpolate from 1 kilometer, it will not give you the results. But that kind of fine resolution extraction is possible if there are at least few monitors to train your model.
So because we don't have monitoring stations, actually, I'm from Department of Ecology, Environment and Remote Sensing. We are most concerned towards the implementation part. We are doing research as well, but how we can implement on the ground. So that's the main.
Yeah, so that's what I was just talking to someone on, with them actually during tea time, and I said that if you do not have, I don't know how many monitors. I think in Jammu there is only 1 or 2 monitors, right?
Sir, in Srinagar only 1.
Srinagar only 1. Okay, so what can be done is that, see, to train your model, you need some spatial contrast. So if reference gain monitor is not possible, you can think of using some portable sensors, calibrate them and deploy for shorter duration. And using that, actually, you can train a model very well to predict at ward level. Or even I was just giving them examples that using these low-cost sensors, you can actually evaluate the efficacy of the local interventions. And I have some interesting results where we actually see that, when you sprinkle water on a road, how much it is removing the pollution level and how long that is also effective. And particularly we did the exercise on the road between IIT and JNU, and we see around 3 hours is the impact. And many of these things can be done. We need longer discussion.
Yes, sir, I definitely want to have. Thank you. Any other questions?
Anyone here has used, students, any satellite data ever for this type of analysis? You know from where you can download the data. So there are few websites. Is it possible actually all these things are open in this particular lab? Can you, it's locked?
Yeah, because this is hands-on session, no? So all of you can open your laptops and
This has to be connected.
Konika, you have installed the folders now. What is the latest? Download.
Online.
Has anyone all these will be required, and then there are some other files which are also open. So I just need this laptop to be connected. So if you are a beginner in satellite, my suggestion is that you can download most of the basic satellite data which is out there. No new product or anything. Whatever is existing, that also you can use and do a lot of things. So the best website is the NASA website, NASA data portal actually called Giovanni. Giovanni. If you Google Giovanni, it will appear, and then you should create your own account. All the data are freely available, because otherwise you cannot download more than I think 1 or 2 months of data. They made some restriction. Yes.
When we download the data from there are still gaps.
No, gap will be there, because that's what the basic satellite is doing. That's what I'm saying, that if you want to then further improve this product, you have to do all these additional things. But again, in Giovanni, you will only download level 3 data, which is the typical gridded data. If you want to download level 2 data for research purpose, you just directly go to that particular sensor website. Like MODIS, there is a proper MODIS data portal. MISR, there is MISR data portal. Download the NetCDF file. Most of these files are available either in NetCDF format or I think CSV format. Anybody here, students again targeting, like, have you ever used NetCDF format files? If not, then you have to learn how to handle these NetCDF files.
No, I don't. High split model. Simply high split model.
Okay, so is that laptop connected or something?
Sir, I'm just trying to open the link. High split model.
Okay, but there are some other folders I wanted to also show them.
It will be copied. That software is.
The software is not required, but I think she has downloaded. Then the entire folder has to be copied. That OPEC folder. Anybody here use that software OPEC?
So there was an instruction note that you have to.
Okay.
Who has not downloaded, you can download.
No, I can show. I mean, later on they can download and all, but I can just give them a familiar, because otherwise, if you download, there are so many files, they will be clueless what to use, what not to use. So I thought in short time.
So if you don't mind, you can come. You can use.
Yeah, I can come down. All I need is that laptop. It's not possible to connect.
Actually, online streaming is going on. Then we have to start.
All the content will be copied to this one. सारी चीजें इस पे copy हो जाएगी फिर आप सब
Then we have to start.
Okay, all right.
Actually everything ये online जा रहा है ना सर फिर disconnect करके close.
अच्छा, फिर ये जो लैपटॉप है ना ओपेक का जो पूरा फोल्डर है इसमें फिर कॉपी करो.
ठीक है.
कैसे करोगे?
पेन ड्राइव में
पेन ड्राइव. तब तक मैं ये करता हूँ, फिर इसको माइक दे दो मुझे.
कॉपी करना.
Okay, let me show. I can see that screen. So yeah, this is actually the Giovanni website for those who are not very familiar. So you have to Google Giovanni, NASA. Otherwise, it will take you to some Italian fashion website. But yeah, so this is the website. You create your login, which is free, because without login you can have limited access. How to choose? So you can see there is a series of data sets. For example, there are 266 different data products for aerosols. If you are interested in aerosol studies, you click here. Then all the available data products will appear. Is it connected to net?
Yes, sir.
I don't know or something. Yes, you will get also data, vegetation data, if you are interested. This OPEC. Hold on. नहीं यहीं पे रख लो, इन्हें तो उसी से कर लेंगे। अच्छा चलो कॉपी कर लो।
अच्छा एक्सट्रैक्ट करना सर।
इसको एक्सट्रैक्ट करना
ओके
है।
ओके।
फोल्डर बनाओ और उसमें जो है SW2023 करके डाल के फिर उसमें एक्सट्रैक्ट करो सारी चीजें उसी में। इसको ड्रैग करके
ये चीज है
Okay, let me first show Giovanni. Yeah, so now you see that all 266 files are shown here. Why 266? Because it has multiple sensor, different data products. For example, you can see OMI sensor. There is a daily product at 1 degree on aerosol absorption optical depth. This is not aerosol optical depth, but only for the absorbing part. So these are all self-explanatory. You can see multiple different products, aerosol optical depth from Miser, daily data, sea waves, whatever you need, you choose. For example, if you are interested, let's say in aerosol optical depth, so click this, and then when you download, what you have to do is that you have to specify 3 things. You have to specify the lat long, which is here. If you want to download global data, so just the bounding box minus 180 degree to 180 degree. Again, these are self-explanatory. You can see minus 180, minus 90, 180, 90 degree. Then you have to specify also the date. Now, if you are downloading monthly data, obviously only month and year is required. If it is daily data, day also is required. Now, once you choose all these things, what it will do is that it will plot the data first. Now, that also you can choose here. There are multiple plotting options available. You want time average map, you want, area average time series, anything you want, you can do this. Now, once the map is shown, obviously after choosing everything, you have to click on plot data. Let me do one example. Let's say Miser daily data. Keep it global. And I'm doing 2-3 days just to save time. Time average map means it will just generate a spatial map. Oh, sorry, this, let me, yeah. So once this image is created, whatever you have chosen, you can actually download the data also. So that's where actually your work should start. I mean, you can get this kind of visualization, that is fine, but you should download all the data. As I said that you can use this web portal or you can directly go to other website. Directly. So yeah, so this is just 2-3 days average of Miser AOD. Now Miser has a narrow swath. It takes at least 9 days for global coverage. So when you average for 2-3 days, you see lot of data gap. Okay, so you can only see where the swath is moving. You have some data. Now, if you click on here, download, then it will ask you actually in what format you can download, whatever format you are comfortable with. But if you want to process it, I would rather advise you either download GOT for NetCDF. Now the same data can be opened in another software called Panoply. Again, it's a visualization software. But if you want to process anything, you must learn some data analytics software. Otherwise, you cannot process. Let's say if you're interested in looking into 10 years to 15 years of data, you cannot manage in simple Excel or any other these things. So this is one website where huge amount of data is available. Any component you keep, usually all the data are available. You can see, cryosphere, ocean, hydrology, atmospheric dynamics. Now, what they have done is that in addition to aerosols, they have also put a lot of meteorological data in this particular website. It's taking too much time. Anybody here has used this wind trajectory? Students, we have used, right? What I will also advise is that, so that means you know how to generate the wind trajectory data. Now, when you look for wind trajectory, it gives you very broad idea about what is the major direction from where the wind is coming. For more quantitative analysis, what you should do is that, let us say that you identify 3 or 4 major clusters. If you produce a cluster trajectory, have you ever done cluster trajectory? Yeah. So let's say you have one cluster coming in this direction, another cluster. Ideally, what you should do is that if you are doing a measurement, let's say here, Jammu, and then you look into wind trajectory. If you are doing a measurement almost every day, you can segregate your data based on those wind clusters. And if you do that, you will get much more insight rather than just saying, okay, this is typical wind direction. For example, in Indore, we were doing these measurements and we clearly found actually that there are certain directions from where the wind is coming on those days when the pollution level is very, very high. So you can clearly identify then the potential areas which is actually leading to high value. So what I'm saying is that just don't generate the wind trajectory data, but do more analysis after you actually get it. So here you can see actually a lot of other data sets are also available, beyond just the aerosol, any weather informations. Anybody is using any reanalysis data? Like if you want actually meteorological information to understand, wind pattern, boundary layer height, right? We all know that boundary layer height is so important. Have you ever downloaded any data for boundary layer height?
I have previous data.
So, okay, you are using ERA 5 data, right? So you can go to ERA 5 website, download the data. Our NCMR WF also has a now data product at finer resolutions than ERA 5. So if you go to NCMR WF, people know what is NCMR WF? This is the Ministry of Earth Science National Center for Medium Range Weather Forecasting. So if you go to NCMR WF reanalysis data, now they have a fantastic data set, much finer resolutions than ERA 5. You can download hourly, single level data, whatever is your preference, special level, hourly, 6 hourly. So for example, you can see, they have divided kind of popular and all based on how frequently people download. Yeah, so you can see surface wind, U component, V component, zonal meridional wind, wind speed, 2 meter air temperature, surface temperature, visibility, all these different data sets. Multiple types of rain, then cloud information, radiation data. Soil moisture data, if anyone is working on agriculture and other aspects. Evaporation data, people are using hydrological model and other things. And at least for the last 30 years, data are available. Again, you have to download the data. Obviously, you have to create your login ID to download unlimited data, and you can do your own analysis. Yeah.
Can we download the atmospheric visibility data?
Yes, it's there. Yeah, 2 meter visibility.
This is horizontal visibility.
Yes, the way you define visibility. Yes, it's a gridded data product. Obviously, again, my advice would be that quickly do a validation, because this is reanalysis. Reanalysis means model derived, but in the model they assimilate satellite data products. So reanalysis is not again direct measurements. So it's a hybrid data product where satellite data are assimilated in the models, and then you run the model to produce the data in a gridded format. It should give good quality data because they have done a lot to make sure that you capture all the Indian, the climate conditions and all. But yeah, I mean, if you're interested in visibility, so this is your data product. Then, yes, yeah. And there are many other data set also available. For example, if you're interested in any ISRO data, then you have to create a login in the SAC satellite data web portal. But if you want to have a quick look of the ISRO data, then you go to Rapid website, rapid.imd.gov.in. So this is just a visualization portal. From here, you cannot download the data. This is just to check. But if you have to download the data, go to SAC web data portal. SAC is a Space Application Center, ISRO. So there you have to create your login. Once it is approved, then you can download whatever data you want. Satellite data, all Indian satellite data, because Giovanni has all the NASA and European and other satellite data. It does not have any Indian satellite data in the Giovanni portal. Mostly in Indian satellite, we have geostationary satellites. So they are only covering the Indian regions. But again, in the Indian satellite, we do not have much data product for aerosol and other things. Mostly our geostationary satellites are for weather applications. So you will see data about clouds, rainfall perhaps. There is an AOD product from INSAT 3D and 3DR, but that AOD has very large uncertainty. You can still explore that data. But geostationary satellite data, you will get the advantage of geostationary satellite. You all know that it provides every half an hour data. So that you have to download from the Space Application Center. So satellite, and then you can go to any, for example, satellite website. Like if you are interested now, there is a geostationary satellite which covers almost entire India. This is actually this Korean GEM satellite. And there is also another satellite, Japanese satellite called Himawari. It also covers almost up to, I think, Haryana. Geostationary satellites, you will get actually half-hourly data of aerosol, trace gas, many other things. So you have to then go to that particular website and the same process follows. What I suggest is that you start exploring some of this, then get a feel, and then if any problem is there, feel free to reach out to me. What I will now do is that I don't know how much time is left. So I heard that many people are interested in actually calculating that.
25 minutes.
Oh, okay. So many people are interested in calculating radiative forcing. All these measurements that you are doing. So this is a two-part process. So let's say that we are doing some measurement here. You are measuring black carbon, many other components, and you want to understand what is the radiative forcing. Two-step process. The first step is that based on your chemical measurement, you have to calculate first the optical properties. Because what you are measuring is at the surface, you need columnar aerosol optical depth, single scattering albedo, asymmetry parameter, and many other parameters. Once you have those optical properties, then you can put those optical properties as input to radiative transfer model. Two-step process. First, you have to calculate the optical properties, and that optical property calculation you can do using this software called OPAC. The OPAC output will be these optical properties which are columnar quantity. This columnar quantity will be input in the second step where you use a radiative transfer model. And again, there are multiple radiative transfer models, but the most frequently used in India is the SB-DART model. Now, I use a different machine and all, but I think there is a version of online version of SB-DART, if I am not wrong. Let me try to open that. Yeah. But there is also a MATLAB tool. There is a Fortran code available. Whatever format, you are comfortable with, you can do. But I think in online also you will get the overall idea. But let me first show what is in the OPAC. So in the OPAC, if you download this folder, you will see these two things. There are two folders for that. This folder, OPT-DAT, it has actually the basic aerosol microphysical dataset, based on which actually the model will calculate the optical properties. These are self-explanatory. For example, this is for cirrus, many other things. So it actually has both cloud and aerosol. So these are water-soluble component at different humidity. So water-soluble WaSO00 means water-soluble at 0% humidity, complete dry. Then at 50% humidity, what are the properties? So I will just show you one example. Let's say if I open this. So each file is something like this. You are all familiar with the typical aerosol size distribution, log normal size distribution. If not, you can go through it. So all aerosol species can be represented by log normal size distribution. It means that there is a range of size. So for example, water soluble particles, they consider between this range, 0.006 micron to 2.5. I mean, that is the typical size distribution, but obviously if you plot it, sigma is the width of the log normal size distributions. So if you know these things, you can also actually calculate or generate the size distribution, but the basic data that goes into this model is this. Now you see that what each data file is having is that a different wavelength. So this is the 0.25 micron, 3 micron, 3.5 micron, sorry, 0.35 all the way up to. So it means from UV to typically near infrared range. And each of these wavelength for this particular species, what is the extinction coefficient? Anybody, all of you know what is extinction coefficient? Extinction coefficient is what? Anybody? If you are using AOD, what is AOD? Aerosol optical depth. What is the unit? Why it is unitless? Because it is columnar integrated extinction. When I say column integrated extinction, there is no board, but extinction coefficient is what varies as a function of height. An extinction coefficient quantifies how much the solar radiation is attenuated. Okay, an extinction coefficient depends on three things. One is the size of the particle. second is the number concentration, and third is the efficiency. Okay, there is no board anyway. So extinction coefficient usually represented by beta extinction. Beta extinction, if you consider unimodal distribution, that means all particles are the same size, then beta extinction equals Q. Q is the extinction efficiency multiplied by pi r square. Pi r square is your effective cross section multiplied by N. N is the number concentration. Now, if I ask you these three things, what are the units? What is the unit of extinction efficiency Q? If it is efficiency, what should be the unit? Efficiency is always unitless. What is the implication of efficiency? Implication of efficiency means how efficiently the particle can scatter or absorb radiation. It is unitless. Pi r square, what is the unit? R is radius, so it's a length square. N is what? Number concentration, number of particles per unit volume of air. So what is the unit? Number of particles per unit volume of air. So it's 1 upon length cube, 1 upon meter cube, 1 upon centimeter cube, whatever you take. So what is the unit coming for beta extinction? You have length square into 1 upon length cube. So 1 per length, inverse of length, that is the unit of extinction coefficient. So if you calculate extinction coefficient, that is why you see here what unit is written, 1 upon kilometer, inverse of length. If you plot that extinction coefficient as a function of altitude, you will see usually at surface you have high value. As you go up, it decreases. Now, if you integrate from surface to top of the atmosphere up to where you have aerosols, it means this is your aerosol optical depth. So you have 1 upon kilometer. Integrate means 1 upon kilometer you are averaging over some depth of atmosphere, which is in kilometer.
Top to down or down to top?
No, integrate down to top. Right? So 1 upon kilometer you are integrating. That means 1 upon kilometer multiplied by some kilometer. This is why AOD is unitless. Because this is column attenuated extinction. So these data sets, what is there in OPAC, this is based on the measurements people have taken. So for every wavelength, for this particular aerosol species, what is the extinction coefficient, what is the scattering coefficient, absorption coefficient, this data is compiled. What the model will do is that model will read these files, and then it will calculate based on whatever you are choosing. Now, the ratio of scattering coefficient to the total extinction coefficient is the single scattering albedo. So single scattering albedo is the second most important property of aerosol, which tells us about how absorbing or how scattering are the particles. Anybody knows what is asymmetry parameter? Asymmetry parameter is the directional, it considers the directional scattering component, because the particles, when they scatter radiation, they never scatter in one direction. There is a distribution. In some direction, scattering is more intense, some direction it is less. So if you have to consider that directionality of scattering, that's actually asymmetry parameter. And these are all calculated based on the refractive index. So in this way, for all different species, the data are compiled. So water soluble, sea salt, water insoluble, soot is basically black carbon, then mineral dust and all. So this file usually you don't touch. This is the basic data file I just showed. What is the file that you will actually use is this other one, OPAC 31, where you can see two folders, input, result. And this is the executable file which you will run on your machine. If you just double click it, it will run based on the input parameters that you have defined. And when you run it, you will get the output. So your input file is this one. Here you have to make changes. Yeah. This is the input file, opac.inp. This is where you will define the input parameters for your own case, whatever you are interested in. So I will go through one by one. This input file has 5 important points to choose. First, you have to define what type of aerosols you are interested in. You can also do for cloud, but let's say today we are discussing with aerosols. So it has all these 19 options. Is there a way to enlarge it? People can see, right? So for example, you see that there are some standard aerosols mixture, it is already defined. For example, continental clean. Then number 2, continental average. If you are a beginner, just fun playing with it, you can choose any of these. So these are kind of standardized aerosol model. Where you will put this? Here. So if you are interested in knowing what are the optical properties of continental clean type of aerosol, instead of 0, you will choose 1 here. But most practical sense, you will never go with any of the defined mixture. What you will rather do is that you will define your own aerosol type based on your measurement. So own mixture is 0. Define new mixture. So here actually I am making these changes 0. Once you click here 0, then it will ask you that okay, if you are interested in defining new mixture, what in your aerosol mixture, what are the components that you want? So again, you have the luxury of choosing from maximum 5 types. Next step. Now, what are these 5 types? Obviously, these are the types. You can choose insoluble particles, water soluble, soot, sea salt in 2 different size mode. One is accumulation, one is coarse. Mineral dust in nucleation mode, in accumulation mode, in coarse mode. Transported mineral dust. Sulfate. Now, typically this sulfate in opaque is actually for the stratospheric sulfate. Usually people use this when there is a volcanic eruption and you want to know what has happened. And then you have a bunch of cloud parameters. So if you are interested in cloud, obviously then you will go for these cloud parameters. So now in your case, if you are defining your own mixture 0, you have to choose from these 9 different types of aerosol. Now I don't know if anyone is doing some measurements in Jammu. What out of these 8 or 9, what type of aerosols you are measuring? You are certainly measuring some water insoluble, water soluble, yes, right? You have sulfate, nitrate, black carbon, definitely you are getting here. So whatever you are getting, you have to then choose accordingly. Now here you see in your new type, as I said, you have the option of choosing 5. If you choose number 1, it means insoluble. Now the input here is the number density, number of insoluble particles per unit volume of air. What you are measuring is the mass concentration. You've done some measurement, I think in the last 2 days you are getting some training, right? Let's say if you are measuring black carbon. The black carbon concentration is, let's say, 1 microgram per cubic meter. Here your input is not mass concentration, your input is number density. You have two options. You can directly calculate what should be the number density for 1 microgram per cubic meter black carbon mass concentration. And that number density you have to put it here. So 3 is black carbon, and then after comma is the number that you want to add. When you run the model, the output file will actually tell you what is the mass concentration based on the microphysical data. So that derived mass concentration should measure your measured mass concentration. Otherwise, your input number concentration was wrong. You have to make changes there. Okay. So in this case, for example, randomly you have seen 1, 2, 3, 4, and 10 has been chosen. So some number for insoluble, some for water soluble, black carbon. I don't know, here it is 4 is what? That's a sea salt and then something else. But you can make these changes. If you do not need water soluble or insoluble, you can just remove 1 and put anything else. 9, mineral transport. So this is what you have to do first. Based on your measurement, first fix what? 4 and 4. Now, maximum 5 you can choose. But if you say that, okay, I don't have 5 species, major species. I have only 4. You can go with 4. Then all you have to do is that in the 5th place, you just make it 0. So that means there is no... But usually, you will always get 5 species to choose from. Insoluble, water soluble, black carbon anyway will be there. Then you can choose from dust and other particles. Then the next important thing that you have to fix is the height. Because keep in mind what you are giving input is based on your measurement at the surface. So you have to here define the scale height. Usually we don't touch other things like stratosphere or free troposphere and other things. Now, mostly you can make changes here in the mixing layer height. If you know what is the mixed layer depth based on some measurement or meteorological data, then this first is mixed layer, and these 3 things you have to make change. What is the lower altitude of the mixed layer, what is the upper height, and what is the scale height. Okay, you can calculate the scale height based on the temperature profile. Even if you don't touch it really, you can keep the default values, but if you change slightly these numbers, you will see your calculated optical property will slightly change. So advice would be better to use the actual mixed layer depth rather than some average value. Then the third thing what you have to choose is wavelength. So number 3 is wavelength. Choosing wavelength means you are asking the model to calculate only for those specific wavelengths. Now keep in mind that the next step would be to put these outputs in your radiative transfer model. In your radiative transfer model, if you want to calculate the short wave radiative forcing, then you need at least 5-6 different wavelengths in the entire range of short wave to calculate these optical properties. If you calculate only at one single wavelength, then it is too much approximation, because all the optical properties vary as a function of wavelength. So ideally you want these optical properties at multiple wavelengths. Now again, there is no fixed rule which wavelength you should choose. But because the satellites and most of the ground radiometers measure AOD and others at 500 or 550 nanometers, so this is what usually we choose. So here is the wavelength, and here wherever you see 1, it means you have chosen that wavelength. If it is 0, you have not chosen that wavelength. You can make all the wavelength 1. It means then the model will calculate the optical property for all the wavelengths. But perhaps you do not need all the wavelengths. Unnecessary, it will add to the computation. So only few wavelengths should be good enough. Now, then the fourth point is, anyway, serious you are not doing. You need to also choose at what relative humidity you want to calculate the optical properties. Some of the species, you have seen that their microphysical properties are humidity dependent, like water soluble particles, sea salt. If the humidity increases, extinction changes. Black carbon does not depend on humidity. So for black carbon, it does not matter. You should choose the humidity based on actual data. Let's say if you are doing measurement today, whatever is the relative humidity. Now, obviously, ideally, let's say if it is 75%, there is no way to choose 75%, so you have to use the nearest value. If it is 75%, the ideal thing would be you choose 70% and 80% both, and then you interpolate back. At 75%, what should be the optical properties? Brown carbon is not included as of now. Yes. Here you cannot calculate, so you need then to develop the optical database for brown carbon. Add here as an individual, because you see that the list of aerosols do not consider brown carbon. So that can be taken as a very fantastic research topic. No, you need microphysical properties for brown carbon at multiple wavelengths. Then you have to add in OPAC that database. You have to make changes in the code. What I'm saying is that this is fantastic idea. It definitely is worth doing a PhD. But then you are actually trying to make changes, which I always like. If you're really trying to do new things. But as of now, brown carbon is not there because there is no robust database for brown carbon. Then last one is actually what optical properties you want as out. Usually what we need is extinction coefficient. So all one. So this top panel is what we usually choose. You can also choose, let's say if you're interested in visibility and all. So this is the input file that you have to be very careful in choosing. Once you choose this, close it, save it, and you go to your output file. So when you run this executive file, output file will be generated, and this is the result that you will get. So this is the result for that default whatever input file was there. So it says that you have chosen 5 components, 2 relative humidities, 10 wavelengths. So at 2 relative humidities you see now, this is the database, and this is the output. That at 50% relative humidity, at different wavelengths, what is your extinction coefficient? What is your scattering coefficient? What is your absorption coefficient? What is your single scattering albedo for your mixed aerosol model? What is the optical depth? So whatever we have chosen randomly, at 550 nanometer at which satellites are measuring, the optical depth is 1. So this is very high aerosol optical depth. Usually you don't get that high aerosol optical depth. You can check actually, as I said, whatever number concentration you put, like shoot 66,000 number density or something was there as an input file. So yeah, that is a very large number. So you can see the mass concentration is 3.68. So this is where you should check whether your input file is matching, because you have measured the mass, you have given number as an input, so you should get back the same mass, close enough. Once you are satisfied, then this is your result. Now this data is what will go now as an input to the radiative transfer model. This is the first step. From where you will pick up the optical depth, single scattering albedo, and many other things. Now next step is radiative transfer calculation. Again, for that I said you can download the code and do, but I'm just showing through using this online tool.
Sir,
yes.
What we have already this data, ground-based measurement. and you can directly put in that model what we have, if you have that data set already we have.
Which data set?
Yeah, that optical data set from ground-based measurement.
If from ground-based data you if you are measuring from ground, let's say optical depth itself, yes, then you do not need opaque at all. Then the total aerosol optical depth that you are measuring using some radiometer at ground, you can directly give that input to radiative transfer model. Unless you have an aeronet, you will not have the other radiative properties that are required for radiative transfer calculation. See, with only aerosol optical depth, you cannot do radiative transfer calculations. You need single scattering albedo, you need asymmetry parameter. Because unless you specify how absorbing or how scattering are aerosols are, you cannot calculate the radiative transfer. So if you have an aeronet, which we have one, there is one in Kanpur and others, there you can directly use the columnar single scattering albedo and all in the radiative transfer model. Okay, here you see it is slightly more complicated than opaque because it asks many things. To simplify, what you need is, now you can calculate aerosol radiative forcing in two conditions. One in clear sky and another in cloudy sky. If cloud is present, then also aerosols interact with radiation. If cloud is not present, then also aerosols can interact with radiation. Mostly people report clear sky aerosol radiative forcing. But you can calculate aerosol radiative forcing also in cloudy sky. And if you see the difference between clear and cloudy sky, aerosol radiative forcing, it is very interesting. You will see significant changes in the aerosol radiative forcing value both at the top of the atmosphere and at surface when cloud is present. Aerosol surface radiative forcing, can anyone tell me what should be the sign of radiative forcing for aerosols in short wave? Because aerosols mostly interact only in short wave, they hardly interact with long wave. So in short wave, what is the sign of the forcing that we are expecting? Oh, okay. So I am asking that whether you are expecting cooling or heating. Aerosols contribute cooling. So if it is cooling, then the radiative forcing is negative. At surface, it is always negative. If you are getting aerosol radiative forcing some positive number at the surface, that means you have made some mistake. Aerosol radiative forcing cannot be positive at surface. No matter what type of aerosol is there, at surface, there is always cooling. So surface radiative forcing is always negative. At the top of the atmosphere, the forcing can either be positive or negative, depending on whether you have absorbing or scattering aerosols. And your top of the atmospheric forcing minus the surface forcing is your atmospheric forcing. And atmospheric forcing you will always see positive. So aerosols cool the surface, cool or warm the top of the atmosphere, and essentially they produce this excess heat which is actually lost due to the attenuation. That excess heat is stored in the atmosphere. So this is what aerosols do. Now the radiative transfer model cannot give you also the forcing directly. I don't know how much time we have.
We have to move for lunch.
Okay, I think then maybe
during lunchtime we can discuss. If we want to show anything, we can do it.
No, that will take some time, but this is also self-explanatory. I suggest everyone you can go through this. All here, multiple things you need as input. For example, solar zenith angle. So you have to specify at what solar zenith angle you want to calculate the radiative force. Because solar zenith angle varies, right? So if it is 0, if you do not do anything here, then by default it will consider 0. That means the sun is on the horizon.
Sir,
Yes.
सर ये RRTM और CRTM मॉडल जो हमारा है का उसमें बेसिक डिफरेंस क्या है क्योंकि अभी CRTM यूज करते हैं.
There's slight difference, so that's again parameterized version. These are all one dimensional radiative transfer. Then you see that you have to specify wavelength. If you are interested in short wave, then you put it here 0.25 to 4. This is the typical short wave which we consider 0.25 to 4 micron. The other important point I will say that if this particular first thing, output data, the model will give you is the flux, not the forcing. It will calculate 4 things. What is the incoming and outgoing flux at the top of the atmosphere, and what is the incoming and outgoing flux at the surface. That means how much radiation is reaching the surface, how much is going back from the surface, how much is coming from sun to the top of the atmosphere, and how much is going out of the top of the atmosphere. You need these 4 numbers to calculate your radiative force. So when you run the SB model, you have to go for these 4 numbers: total downward flux, total upward flux, total downward flux at the surface, total upward flux at the surface. All 4 you have to calculate. Then you have to calculate further the radiative force. So maybe in a lunchtime I can say tell you how to calculate this, and then you have to specify all other things, because in real atmosphere you have species. If you don't do anything, it will have some default atmospheric composition. How much nitrogen is there, how much oxygen. You can make these changes. Cloud, if you don't do anything, it will calculate for clear sky. If you want to calculate aerosol forcing in cloudy sky, there you have to specify the cloud properties. What are the cloud optical thickness, at what height cloud is, and all. Just play around it. I think it will be fun. And then you have to choose also the optical properties directly here in the boundary layer aerosol. You see, it is asking for your aerosol optical depth. So you have to put whatever you have calculated, extinction efficiency, and many other parameters. Then you run the model, click here, force replot. It will give you actually the output of those numbers. And in your output, choose just the final thing before I disperse. Where is that output? Oh, here. Y unit. So what you have to do is you can choose spectral flux density, but that will not give you the integrated value for the short wave. So you have to basically, because you have already chosen a range, so the output will actually kind of give you the average value for this entire range that you have chosen. So once you then get these fluxes, you calculate then your radiative force. But it's not learning, mechanically, I have to do this, I have to do that. If you understand the whole process, then you can actually make it more meaningful, effective. Otherwise, you can make mistake, and then you will not be able to rectify that mistake if you don't understand the whole process. So never do this mechanically. Understand the process, and then maybe in the lunch you can actually continue this discussion.
Yeah, thank you so much. Once upon a big round of applause. I will still not say that the session is closed for Professor Sagnik, because the discussion will be on. But I want to extend my heartfelt thanks to all your time you have